So on number 7, your derivative should have been 0. Yes?
7?
Oh, not 7, whatever that number is.
It starts at 11.
11. On number 11, your derivative should have been 0.
Are we going over answers?
Are we doing notes?
We're going to do something with this.
Well,
Okay? Your derivative should have came out to be 0.
Yeah.
yeah.
Okay? On number
12.
13,
12.
I'm pretty sure 13 is negative 10x. Yes?
Yes.
Okay?
Oh, you keep the X?
Oh, no, that's the not derivative. That's the...
Oh.
You guys want answers to evens, don't you? Okay, so on 12, your answer should have been 0.
These.
Can we just
On-
speed through all of them?
What? I was just going to do... Okay. 11 is 0. 12 is 0. 13 is negative 10. 14 is 3.
What is it? 3?
3.
Ooh.
15 is 2/3. 16 is negative 1/5.
Ooh.
17 should have been 2x plus 1. 18 should be negative 2x. 19 should be 3x squared minus 12. And 20 should be 2.
We didn't do 20.
Oh, you didn't do 20?
We did 25A.
Okay. So 25, you're just supposed to find the derivative again, so it should have been 2x. And 30 what?
31A.
31a. Oh, shoot. I gotta work that one out. I gotta write a little bit.
I need help with 1930.
Okay, so 31a should get 1 plus x. X negative 1. So you get
So we're still using the same.
Yeah, like with an X instead of C.
And it's just 7.
Okay, so on 31, your derivative should have been 1 minus 4 over x squared. Or x squared minus 4 over x squared.
4 over x squared?
Wait, can you?
1 minus 4 over x squared.
You could have it like this, or you could have it like this. I don't know which way you would have it.
Your camera's not up. Your camera's
Oh, I'm sorry.
Cursor. What?
Oh, and then I gotta do the password.
Stop judging, Sadie.
Yeah, thanks, Riley, for having my back. Maybe don't bring a cup with
Hey,
song names
hey.
on it.
Okay, so you could have it written either of these two circled ways. You could have 1 minus 4 over x squared or x squared minus 4 over x squared. Which way do you have it? The first one or second one? The first way? Okay, so either way.
I couldn't figure it out.
Okay. That one was more of a challenge one because it had the fraction with it. Okay, so what we're doing what? 32a? Oh, okay. Negative 1 over x plus 1 squared, or you could have negative 1 over x squared plus 2x plus 1. Either one of these is correct.
Alright, I'm coming in during it.
Okay, but those were more challenge ones. I am not going to focus on the rational ones. Okay, you're going to find rules for those.
So
Okay?
I could turn it in with them. Those
Did you, as long as you tried them.
Yeah.
Okay, then I'm fine. Again, I'm not stressing over the rational ones. Those were more to push you to see if you could put them in.
That's just 25, 31, and 32.
I struggled with 19 too. I don't know what happened on that one.
So you can come in on those ones, but anything with the rational, with the fraction, I'm not overly concerned about it. Okay, 25 you should have been able to do.
I'm really confused.
Okay.
Alrighty.
Okay. Well, none of this is, you don't know how to do any of this.
No, I know. I'm talking about number 11. It just has one number.
So, yeah.
It's just 7.
It's just 7.
Over.
It's just 7. It's 7 minus 7 over the change of x.
Which is 0.
which is 0 over 0. So 0.
Just keep forgetting to change x, even though it says like we write is 0 every single time. And it's the same thing for 12.
Yep, same thing for 12. Okay, so what we need to do with this today is we're going to be identifying graphs. Okay, so this is 15, this is 17, and this is 19. Yes? Those are the problems for 11, 13, 14. Okay, so when we find a derivative, we're finding the slope function of the function, yes? Okay, so we're finding a slope. A derivative is a slope function of a function, yes?
Yeah.
So if I get 0, that is the slope of the tangent line, yes?
Mm-hmm.
Are these the notes you want us to write?
If yes. Okay, so this is the slope of the tangent line. Well, if I have a 0 slope, isn't that linear? Doesn't it look like this?
Yeah.
Okay, so if I put this, and actually it's specifically the x-axis, right? So I'm going to put 7 in here, and I'm going to put 0 in here because that's the derivative. There's 7, and there's 0. See the red? Okay, so if I ask you to identify the slope of a constant, it's going to be at where? Or the derivative. The graph of the derivative of a constant is going to be what?
0.
0. Okay. So now, the derivative on 13 was negative 10. Now this is f prime of x, right? Derivative. And this is f of x, so I have f prime. That's how I write derivative. And this one was negative 10. So this line right here is a linear line that goes through 0 with a slope of negative 10. Correct? Negative 10x, that's what it is. Well, this, if it just says negative 10, isn't that a horizontal line at where? Negative 10. So, let me graph it. So I have negative 10x, and we have negative 10. Probably need to make my window a little bit bigger. And there's the graph. The graph of the derivative is in red. Do you see what's going on? This derivative is that slope function, correct? Okay, so now we have 3 plus 2/3 s, and so not f anymore. This is h, huh? So it's h prime at s was 2/3. Well, that's a horizontal line at 2/3, isn't it? So let's look what the graph is going to look like. So 3 plus 2 divided by 3 x over, not over. So there's the first line, and there's the derivative at 2/3. You get what I'm getting at? Mm-hmm. The derivative is a constant, so it's just a horizontal line on those. Well, here, my derivative is 2x plus 1. Well, this, what shape is this graph?
Parabola.
A parabola. What shape is this? Linear. Y-intercept at 2, at 1, slope of 2. So when I graph these, I should get a parabola, correct? And a,
Where'd you get the second equation from?
that's the derivative. That's what you found yesterday.
Oh.
You don't know how I got it yet. You'll know that tomorrow. So I should see a parabola and then a linear line. Is that what I see?
Yep.
Yes. Okay, so this derivative is 3x squared minus 12. Well, this is a cubic function. Yes? Mm-hmm. So it starts down and ends up, and it has something going on like that, right? Mm-hmm. And this is a what? Parabola. What do you notice about all the degrees? This was a first degree. This is a 0 degree, yes? First degree, 0 degree. Second degree, what's the highest power? Second degree, what?
First
First. Third,
to second.
second.
That's always
Is
one.
it always going to be one less? Yes.
Okay.
Okay. So then I have x cubed minus 12x. And derivative was 3x squared minus 12. So I better see, there's my cubic, yep. And is there my parabola? It's my cubic,
Right.
and there's my parabola. Got it?
Yes.
Okay, so,
See what's behind that?
Oh.
okay, we need to, I hate that we have two different pages. Okay, so this is a linear line, yes?
Yeah.
What's the slope of the derivative going to be? What's 1 less than 1?
0.
0. So it's going to be a horizontal line, correct? So which one of these, A, B, C, or D, is a horizontal line? B. So the answer to 39 is what?
B.
The answer to 39 is what?
B.
Why aren't you writing it down?
39.
Yeah, look at your assignment from yesterday. Where'd you stop?
32.
Where I understand that. Where did I say? The rest of it is when?
39. This is crazy.
Question.
Today.
So can we add today's assignment to yesterday's assignment?
Yeah. There's only
Is that
one.
good?
There's
Two
only
separate?
one on Classroom to turn it in.
Okay.
Are we doing the 115, 3 through 22 yet?
No, because we haven't done those notes.
39's B.
I thought that's what
Okay.
we were doing now.
No.
Can we do 40?
Okay, so now 40. What degree is this?
2.
Second degree.
Oh yeah.
So its derivative is going to be a
First.
first degree. So it's going to be a linear line
And say that that is second degree.
because it's a parabola.
We just know
Wait,
that.
can we
You
go
should just
over
know
the-
that.
Can we go over the
Do over
like
what we
what every degree
Wait,
is?
No.
sorting the shapes of the graph.
What's a parabola look like?
Okay.
Okay, what's
Second.
cubic? What's cubic look like?
Cubic's like this.
Yeah. And a fourth degree would have just more things going on, right?
And on the same
Wait, what's
And
our
then-
first?
direction. Linear.
Linear,
What's
Wait,
0?
linear is
Line.
horizontal.
Duh. See, this is sometimes I just need.
a little bit of a refresher.
Is it
A
undefined
refresher.
vertical?
Okay, so which one of these is linear? A, B, C, or D?
D.
D.
Yeah.
40's D.
Okay, so now we have 41.
I can do it.
Okay, so we have 41 and 42.
That's cubic.
Yeah.
No,
No,
that's a
it's-
square root.
Oh yeah.
And this is an absolute value, yes?
Yes.
Now, with an absolute value, I have, if I cover this up, do I have a linear line?
Yes.
So that slope would be horizontal. That derivative would be horizontal,
C.
correct?
How do you know that?
Shh. Is that not linear?
Yes.
That's a
Covered up.
first degree.
And then you gotta do the other half. so
Okay,
it's gonna
but
be-
Oh.
you're getting it, Gentry, yes.
I see.
Yes,
I see.
you're getting it. Okay, so this is going to be a negative, yes?
Yes.
A negative slope? So it's going to be a negative number.
Yes.
And this is going to be a
Positive.
positive number horizontal line because it's constant, isn't it? So which one of those has two different positive and
I'd like
negative?
to solve.
Is it this?
C.
Is it
C.
What's that?
Okay? Because I have 1 and 1, but one's positive and one is what?
Negative.
Negative. So this one has to be the square root. So let's figure out why this is this. Because this is square root. It's different, isn't it? So right here, our slope would be basically going vertical, yes?
Mm-hmm.
Now see how this is going here? And it's going? Can you put all those lines here? Because this line, the slope right here would be a vertical line, which would be undefined, which is an asymptote, yes?
Yes.
Okay, and as I go, I'm getting more and more and more, and then my slope is going to gradually get to 0, isn't it? It's going to look like it's 0, but is it ever going to get 0? No, but that's why it goes a vertical asymptote to a what?
Negative.
Horizontal asymptote.
Horizontal.
Okay, so we match those up. Now what's your next number?
45.
45.
Okay, so 45. It says, sketch the graph of the derivative. Okay, so we need, this is linear, so my derivative is going to be what?
1.
Let's go horizontal. So I need to know
Why am I back?
what my slope is, don't I? So what is my slope? If I go through 4, so 1, 2, 3, 4, and 1, 2, 3, 4. So 4 over 4 is 1. So what should that graph look like?
Horizontal.
Horizontal at where? 1.
Should we graph it?
Yep.
Well, that's ugly.
Oh, you drew in the book.
What's my book?
And it's an erased pen.
Because she fancy. Oh, her line was like.
My line wasn't straight.
Been there.
I don't think it's gonna be straight.
Yeah, it's still not straight.
Yeah.
This girl.
Oh. It's closer. Okay, anyway.
I can't.
Oh, now she just did it
Loses
without
the-
it.
All right.
Oh,
Oh, that's
OCD.
worse.
Oh.
It's straight. No, it isn't. It's better than the other two.
Oh,
Okay.
I don't think it is.
So now what this one? What's my slope here?
0.
0.
Oh goodness. So
Which
we're gonna be in the
means-
negatives.
You can't. 1 less than 0. would be-
Undefined. What the heck?
Oh, like that.
That
the heck?
confuses me.
So cool. Wouldn't that be an asymptote though? Or no?
Mm-mm. Wait. Oh, wait. No, I did that wrong.
Oh my.
Sorry. What was our constant, guys? What was our constant derivatives?
0.
0. So it's just what?
0.
I was like,
Can
whoa.
we just draw like a slash line for that? Like it.
Yeah, on yours you
like
could
an
put, yeah.
asymptote?
But it's not an asymptote.
Yeah.
Okay. So what degree is this?
Third.
Two.
Second.
Second.
Stu.
So we're going to be linear, yes?
Mm-hmm.
So we need to figure out how to get a linear out of that, right?
Yes, good question.
Okay, well, over here, let's look at this. Our vertex was at 0, yes?
Yeah.
Okay, and over here, it goes through what? 0. So our vertex is where? 4. So we should go through 4.
Yes.
What's happening?
We have a parabola, and the vertex was at 0, yes?
Yes.
And its derivative, it crossed at where? 0?
Okay.
Yes?
I feel
So
so
we know this one is going to cross at 4 and go positive, and we don't know much more about it, do we?
No.
Nope.
Okay, I see that.
Okay?
So that's all we have to do then?
Yep. Okay, 48.
Whoa, whoa, whoa.
I don't know how you determine where the lines go.
Well,
Would it be
now let's look here. There's
One's
42.
negative.
There's 42, and his answer was C, yes?
Yes.
Okay, so the slope was 1 and 1. You guys see that?
Yeah.
It's like 1 and 1, 1, 1, 1, 1. And it hits, the vertex is at 0, 0.
Mm-hmm.
So this was at positive 1 and negative 1. And where do they, it happens at Y is what? 0. Okay, so let's take that to here.
Why is
We're not going to be at 0. We're going to be at what?
4?
4.
4.
And our slope is 1, 2, 3, 4, 1, 2, 3, 4. So our slope is 1 and 1 again. But instead of being at 1, it's going to be at where?
4.
4. I mean, 0, it's going to be 4. So we're going to have an open circle at 1, and then an open circle at -1. Now, where did I get 1 and -1 from?
The other graph.
No, the slope.
Oh yeah.
The slope. Okay? Now, the reason why it is an open circle and not a closed circle is an absolute value is discontinuous. Remember we talked about those sharp turns? And at sharp turns, it's discontinuous. And also, what is the slope right there? Wouldn't it be vertical?
Yes.
And that would be an undefined point.
I don't understand that.
So we're done with our assignment. We can turn it.
Are you done?
Yes.
Okay.
Awesome.
I-
Awesome sauce.
The basic thing about this is you need to remember how it's 1 degree, yes. Less. Yes?
Yes.
So let's give me,
Is it 1 degree less?
because the way derivatives work.
So the derivative is always
1 degree less. Okay. Now I'm going to show you, I'm going to make some funky graph. You guys ready?
I don't know if I'm ready.
You guys ready?
Yeah.
Okay.
Yeah. Nice pen.
I know, it like ran out.
I need to borrow my nice one I got from Midland.
No, it's
For
fine.
me.
No way.
Yeah.
Okay. So is this an even or an odd function?
It's odd.
It's odd. How do you know that, Shelby?
They end in different places.
They end in different places, yes?
It's up.
Okay. So my derivative is going to do the same thing the end does. So it's going to end going where?
Up.
Up. So every time, what is the slope right here at that point? What is the slope right there at that point?
Zero.
Yeah,
Zero. And what is it at that point?
Zero.
0. And what is it at this point?
Zero.
0. So when I graph the derivative, all these 0 slopes go where? Don't they go to 0?
Yes.
Because you just said the derivative there, because when we're graphing a derivative, we're graphing a picture of the slopes.
Right.
So if the slopes are 0, those would be 0. Yes?
Yes.
And this one would come where?
Also 0.
Also 0. And what?
0.
0. So now we are going to go
Ooh. Oh, that's nice.
I should have drawn that in a different color
Why didn't you roll all the way down with one of them?
because we don't know. We didn't calculate it.
Oh.
Now, do you see did the degree go down one?
Yeah.
Yep, the degree went down one. And actually, it's about an average between the top and the bottom. Like, it shouldn't be completely outlandish on
The
them.
degree went down one from
Yes. Well, because it was odd, yes. It actually was 1, 2, 3, 4, 5th degree. This was x to the 5th, and then something else behind it.
4.
And this is x to the 1, 2, 3, 4.
I get it now.
So if I gave you some random graph, should you be able to give me something precisely of its derivative?
Yeah.
Yeah.
So the
Be-
derivative here would be 1.
No, there's no, I don't know the derivative. The derivative just has some shape like that. I know that at this point, the slope was 0, 0, 0, 0. So I bring it to where?
0.
To 0, and then I connect the dots.
This is for random and physics stuff. I don't know like what we did.
Okay, so let's do it again.
But it will start off with something. Like we don't have to make them both up.
No, not if I'm asking you to make it up. Okay, so this is the graph. Even or odd?
Odd. Even.
Even.
Oh yeah.
And is it odd, even, or negative? Positive or negative? Negative.
What I meant.
So when I end, I'm going to be ending going where?
Up.
Same direction. Okay, so if I went from an even, one less is going to be an odd, yes?
Yes.
So it's going to end down, start what?
Up.
Up. What is the slope right here?
Your peaks will be zeros. Your
0.
maximums.
Your max and mins. 0.
0. 0. 0.
I like. Why is that a 0?
Because what is the slope right here at that tangent line?
Okay, never mind. Forget what I said. I'm stupid.
Okay, no,
Did you forget one?
we've got, no. There's 1, 2, 3. Okay, and so then I do what?
Do you always mark 0, 0 as a 0?
What?
Do you always mark the origin as a 0? Like,
No, that just happened. It's not even quite on the origin.
oh.
It just happened because it's a min. It's the max and mins. Because the slope right here at that tangent line is what? 0. Okay, so now it comes here. I don't know, my arrow's weird. Goes through that 0, goes through that 0, goes through that 0, and ends what?
Down.
Going down. So I started with a 1, 2, 3, 4th degree,
And you're finishing with
and I finished with a 1, 2, 3.
That's so pretty. I get it.
So if somebody asks you, if they give you a sketch of a graph, you should be able to determine the derivative, just not exactly, but do we know it's a 3rd degree? Do we know that it starts up, ends down? Yes.
I'm tired.
How do we know which way it starts and which way it ends?
whatever
But
this.
this one less is going to be opposite.
If this ends,
How do we know it doesn't
if
start
the
down from
function ends down, the derivative ends
Down.
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 Yay! I like how that work.
Yeah. So thank you.
So all that's recorded, so you can go back and watch it
We
if
don't
you
have
need
what
it.
Guys, if we
We did
start
it. We just
doing
did
the,
it.
guys, if we start doing the video.